Hi, my name is Sandy. Today we are going to talk about dynamic programming. So let's think about the Fibonacci problem. As we all know, Fibonacci sequence number is a number where an equals to the sum over the previous two numbers. So if given an integer called n, how can we compute the nth element in this sequence? So an easy way to compute this problem is to use the recursion. Suppose we have a function which takes n as input, and we can simply use recursion, which returns fn minus 1 plus n minus 2. And also we have some corner cases when n equals to 1 or n equals to 2 is simply return 1. So what is the efficiency of this algorithm? Let's see how F5 works over the recursion algorithm. So F5 depends on F4 and F3. And we can construct a tree structure to which how the function is called. And we can see easily in this tree structure that subproblems like F3 and F2 is called too many times. So the problem of the recursion algorithm is that the subproblem of the current problem is computed more than once. So how to improve the algorithm? A simple way of thinking this is using memorization technique, which means we can store the answer of subproblems, and we figure out the relationship between subproblem and the current problem. So in this problem, the subproblem is ai minus 2 plus ai minus 1. And the relationship is this equation. So to solve the subproblem first, we can simply use this a loop. And we will store the answer in extra spaces. In this case, we store the answer of the subproblems in an array. So at the end of the function, we can simply return an. Okay. So now let's consider this time complexity and compares it to the former one. So in the former recursion version, the time complexity is exponential time complexity. While in this function, since here is only one loop in this function, and it is obviously a polynomial time complexity. So it is a much more efficient way to solve this problem. So we can see from this problem we just discussed that the key idea of dynamic programming is to figure out the subproblem and the relationship. The relationship is also called the transmission equation. Once we can define the subproblem and the equation, we can simply solve this. We can simply solve the problem in a much efficient way. So the key idea here is to trade memory for time, which is a common technique used in dynamic programming. So thank you.